Hi, welcome to Hardwire Video. I'm George Tunis, and I'll be taking you through a few basics in this video. We have other videos that will cover cutting of hardwire, laminating, molding, and fusion molding, so be sure to check our website for all those other videos. This particular one is going to cover the different wire types, the coatings, really picking your wire density and what each of the different materials is really designed for. And we'll just see if we can take you through that. Behind me you see a creel basically of our materials. We'll cover in a separate video all our packaging options. Essentially the wire comes in several different types. And I've got two here, and they are completely different. One is zinc coated, and we call this a 12-by wire. In the close-up shot you may be able to see that closely, but on the website just look for the 12-by wire. It's very conformable. It's very easy to move around, so for highly contoured parts, this is basically the wire you're going to want to use. All of our wires are super tough. You can tie them in knots. There's no way you're going to break them. They are ultra high tensile strength cord. 12-by wire, more flexible. As we look at the 3x2 wire, this particular wire has a brass coating on it. This is really our standard product. In the coming months, we'll be introducing adhesion promoted brass. So most of the product you'll see flowing from Hardwire will be brass coated. The 3x2 wire is exceptionally strong. It's a little bit lower priced than the 12-by wire. It's still very, very conformable material. This particular wire has a break strength of about 350 pounds. So as we get into the wire cloth densities, I'll tell you how that we basically design with that. Again, extremely tough material. It can be knotted, things that you just can't do with fiberglass or carbon fiber. The two wires I just showed you are really designed for high tensile applications. Things like infrastructure repair, where you need a tape that lays very flat, it's very conformable, but it's more or less in pure tension. The two wires I'm about to show you are our newest product offerings. And they're designed for folks that are designing or building large composite parts, really that are going to see both tension and compression. Our newest addition to the family is a wire we call the 3XS. Again, difficult to see here in close-up, but if you go to our website you'll see a close-up picture. What we've done with this wire is we've made something that makes, let's say, bad tires. It's not good for tire cord anymore. It's specifically designed for plastics. And we've put 3 core filaments in there. And I think the easiest way to show you is with my hands. In a twisted cord in compression, you tend to generate a blooming stress, and that blooming stress is really what causes a lower compression failure than tensile failure. Our newest cords have 3 large filaments that are essentially aligned. They're overwrapped by a single filament that gives us a strong mechanical interlock, and what we have now is a cord specifically designed for composite plastics, large parts, things like bridge decks, wind blades, places where the laminate will see both tension and compression, where now the compression strength of our material in the end product is actually higher than the tensile strength. So it's a very balanced material, easy to design with. And one of the other things we had done with this wire is we designed in a bit more ductility. We're trying to give the plastics molded with Hardwire more of the best of the metal world and the best of the plastic world. They go together like plastics. They fail in more of a ductile mode, more like a metal. So they're very easy to design with and easy to sell to customers that are traditionally understand the metal world. The last product I'm going to show you is brand new, and this looks an awful lot like fiberglass, but this is the new 3XSF, and we call that the F is for fuzzy. You can see that what we've done here is we've hybridized both the metal structure that I just showed you from the 3XS, which is the X stands for wrapped, the S stands for straight, and we've hybridized that with glass. And what this does is it gives laminates much higher transverse strength, it gives them better buckling resistance, and it gives excellent wet out and wet through performance. So those are the basic tapes. Go to our website, and what you'll find are several spreadsheets that basically detail exactly the different cords, the properties, and you'll almost always see the cord properties up top and then the tape properties below that. Let's talk about tapes. We can take any of those cords that I just showed you and turn it into a wide variety of tapes. When we say tape, what we basically do is we take the cords, we align them in our process, we glue them basically to a scrim that makes them very, very stable, very straight, and then we control the density. We can pick the type of cord, the type of coating, and the number of wires per inch. We have several examples. Here's a coating that has, or a tape that has 4 wires per inch. Here's a particular one where we have 12 wires per inch. And each material is used for different things. Let's take you all the way up to 23 wires per inch. So basically get a good look at 23 wires per inch. And in the close-up shot, if we cut to that, you'll be able to see 24 wires per inch up close on one of the other cameras. Let's talk about how to use these. Typically, this material is used, the 4-wire, 6-wire, 8-wire per inch material is typically used to just build thickness and lightly reinforce plastics. In examples like SMC or infusion molding, you can almost build wire reinforced resin cores, or for SMC, add exceptional tear strength with just a few wires per inch. As we go up in density to something about 12 wires per inch, basically what we're doing there is adding more strength, more stiffness, and we find these materials are exceptionally good for thicker matrix materials, things like cements, latex modified cements. There's enough gap there so that you get some buttonholing where the cement can pass through and kind of glue down to itself, yet there's enough strength, and I believe this material is up around 3 kips per inch, that it competes with the existing carbon materials. As we move into the high density fabrics, this is where you're looking for the ultimate in strength, stiffness, but still have a conformable product that can go into things like wind blade molds and yacht hull molds. Typically this is used with epoxy, polyester, or vinyl ester resins, thinner resins, either in an infusion molded composite or in a wet laid composite. And there's a lot of neat things we can do with these tapes. I have a couple of them out here. One thing that's really exceptional is the tapes are very, very straight. So when we lay these tapes out, they can essentially be laid out very straight in a mold. You don't have to worry about fiber wrinkling, because even if you run over them with a fork truck, essentially you can't wrinkle or tear these tapes apart. In a separate video, you're going to actually see us cut these tapes, and you'll see that they're really stable, they cut well, they don't start to fray. For anyone that's used to using carbon fiber stitch unis, glass fiber stitch unis, this is literally like a Caribbean vacation compared to those materials. It's much easier to use, much easier to lay down. I'm going to demonstrate a couple of those things just real quick. It's really easy to peel wires out of the tape if you want to peel a wire out, and then slitting the tape, this is where the material's great. So if you're on a stringer cap and you need to slit the material, it's extremely easy to slit into narrow tapes. Really the hardest thing is just getting your knife blade started. But it's really easy to turn the tapes into narrow bands. As I said, the material is actually quite conformable. Let's just say we're building a stiffener here. It's easy to take the material, and in one direction, it is extremely conformable, as well as quite pretty. So it's easy to build stiffened structures, hat structures. Again, anytime you have to go around difficult corners, it's actually quite easy. Now last, one of the things that you'll read about on our website is that we can also take these tapes and make them sticky. And here's a good example of a sticky tape. There's only a very precise amount of pressure-sensitive adhesive on here. We can put it on the wire side. This particular tape has it on the wire side, or we can coat the scrim side, depending on what the customer wants and which side he may want out. And the stuff's great. When you're doing a layup and you need to just put the material somewhere, I don't want to mess my mic up, but it's pretty easy to just stick the material just about anywhere. On things like cores, this is where this material starts to work pretty well. On core closeouts, and I just have a quick example of this, it's easy to take the material, and it's conformable enough, even under vacuum, to be able to make the type of core closeouts that you would see in a typical laminate. So under vacuum, that's going to compact well. Again, it's not going to make sharp corners without a pre-bend. Let's talk about sharp corners for a second. One of the unique attributes of Hardwire is the material can be bent at right angles. And the world's made of right angles. We sell quite a bit of the material into this particular application. So it can be bent, so if you're going in a boat transom or around a hard right angle fixing a concrete bridge, this type of performance is very, very important. I'm going to show you one quick thing you can do with these bent angles as well. If I can get it in the center. You can also slit one edge and make all kinds of neat kind of hardwire origami, places where you could make through the thickness inserts for bridge decks to tie the skins together. There's all kinds of ways to mess with this stuff. You can slit it once, you can slit it twice. You can make box sections that go together. You can make all kinds of neat box sections that go together this way. So the possibilities with this material are really, it opens the door to being able to build complex structures that in glass or carbon fiber might be very difficult to lay up. Basically, when you call Hardwire or you go to our website, you're going to be looking at these data sheets, and what we've done there is we've detailed all the different wires for you. We've detailed the density of the tapes, and then most importantly, we've given you the tape tensile properties and their laminated thicknesses, as well as typical composite densities. A typical sample pack from us, just to give you an idea what you would receive in the mail, will have a number of different wire densities. All of them are labeled so that you get the tensile properties, you get the typical composite properties. And if you give us a call and you tell us what your application is, we also throw in one of our famous stiffness counts t-shirts. Well, I hope you've enjoyed watching. Please check out the other videos on cutting and drilling and machining, infusing hardwire. I hope it's been informative. Thanks for watching.